Water drainage system of Mohenjo-daro. 4600 years ago, the city of Mohenjo-daro was at its height. Harappan were ahead the time compared to other contemporary civilizations. Town planning and drainage system were a unique feature of Indus civilization. Mohenjo-daro was discovered by Rakhal Das Banerjee in 1922. This city was divided in two parts, Citadel and Lower Town, around 250 hectares. The citadel was at the height, comparatively lower town and covered by peripheral wall. A book, Civilization of the Indus Valley and Beyond, written by Sir Martin Wheeler. According to him, Great Bath of Mohenjo-daro, constructed with baked brick and gypsum lime based mortar. Asphalt was also used for waterproofing the bath. Near the southwest corner, an outlet led to a high corbel vaulted drain which cut across the loading bay of the granary. Another book, Further Excavations at Mohenjo-daro, written by Ernest Mackay, an archaeologist. According to him, there were 700 wells, some may be public wells. Almost every house had its private bathroom on the platform in the corner of the house. Bathrooms were covered with the wall and connected to the street's drain. Mohenjo-daro had the world's first urban sanitation system. Several houses had both bathing platform and a dedicated toilet connected to the pit. Waste disposal or water exit through the clay pipe emptying into the street drain. Streets drain were constructed by baked bricks and watertight with gypsum, limestone, and bitumen based mortar. Some plaster work also found there. Drains intersect at right angles, making a sign of plus. Drains has been found on the both sides of the street, but some drains have been found in the middle of the street. Drains were covered with baked bricks. More wide drains were covered with limestone blocks. Pits were built down the drains for deposition of solid waste. The pits were helpful to keep the water flow uninterruptedly. These pits were cleaned up periodically. Water of upper story was falling down through a chute or terracotta pipe directly into the street's drain. Level and slope is the key feature of wastewater drainage system. Street drains were falling down into the main sewer. It was very deep and sloppy, covered with corbel 5 to 7 feet deep. A person can pass easily. Two principal drains uncovered, one from east gate and other from close to the north gate. Both were met near the center of the castle and run underground towards west, again turns towards south near the southwestern corner of the castle. Drain cut through the wall and empties out as a cascade into a drain below. Let's inspect the facts about the water management and hydraulic engineering in Dholavira. Roman built the aqueduct to bring the water in the city, but Harappan had done it 2500 BC. Dholavira is an archaeological site situated at Khadir Bet, an island in the Great Run of Kutch state, Gujarat. Locally known as Kotda Timba, means large fort. The city is divided into three parts: Citadel, Upper Town, and Lower Town. 48 hectares area. Outer walls were fortified with yellow brown sandstone blocks. The city was built in a semi arid region. Average rainfall 260 mm annually. That time may be 350 mm annually. It was a drought prone area. Variation in rainfall and failure of monsoon occurred frequently. Moreover, groundwater is found brackish and saline. There is hilly and slopy terrain where water flowed rapidly. Such type of area was not good for habitation, but people of Dholavira faced these difficulties and they discovered its solution to conserve every drop of water and stored into the reservoirs for whole year's consumption. Dholavira lies between two seasonal streams, Mansar in the north and Manhar in the south. The people of Dholavira had built two dams on Mansar and at least three dams on Manhar stream. Two check dams were constructed in the upper part of the eastern side of the Manhar stream so that the velocity of water does not put pressure on the big dam, as well as control the silt deposition behind the check dams. An artificial lake was made behind the main dam on Manhar stream, and a rock cut channel derived from the lake. It was interconnected to the series of reservoirs. There are 16 reservoirs within the city wall. The area reserved for the tanks was immense, approximately 750 meters long along the southern and northern margin. In the west, the tank area was about 590 meter long. Reservoir built through rock cut vertically. These are up to 7 meters deep. In October 2014, a reservoir has been excavated outside the wall in the front of eastern gate of the citadel. This tank has 34 steps descending inwards. The tank measured 74 meters long, 29 meters wide, and 10 meters deep. It is 3 times bigger than the Great Bath of Mohenjo-daro. A drain has been diverted from the main arterial drain. It intersects with this largest tank and enter into the citadel cut through the 7-meter thick stone wall. As a trough, it had connected to another rock cut step well with distillation chamber, carried this water from the tank to hammam, a bath for the elite in the citadel. In the reservoir, a wall with a hole in upper part working as distillation chamber to provide purified water and control the overflowing. Steps were helpful to fetching the water manually when the water level went down. Every reservoir had its separate walls, which was made by yellow sandstone. Bund or width wall of both sides control water velocity as well as chamber for distilling the water. It has a cut into the wall or trough at the appropriate level, parallel to length of reservoirs and citadel's wall, a broad road lined with stone masonry. It was provided all along this road served both bund and a path for easy movement of people. Keeping slope in the mind, several bunds are constructed across the width of tanks to reduce the pressure of the store body on the city wall. These bunds were helpful to store water in selected tanks instead of spreading it out over a large area, which would lead to quick evaporation and seepage. Hydraulic engineering gives to Dholavira a sophisticated water conservation system. It was unique in contemporary civilization even today. The reservoirs covered about 5 hectares, at least 10% of walled area, containing not less than 2.5 lakh cubic meters of water. They stored 54 liters per day for 15,000 people. It was enough water for the consumption till the next rainy season. Another unique feature of Dholavira is reverse drainage system for preventing to the flood. Drains were built at the ground level and drained out from the citadel, which carried the rainwater back to the reservoir. Now search the truth about dockyard. Lothal means mound of the dead, a city of Harappan civilization famous for port or dockyard. It was excavated by S.R. Rao between 1955 to 1960. The city was spread over 7 hectares and divided into upper and lower town. 4400 years old city has 13-meter thick peripheral wall. A higher platform was constructed in the south side of Bhogwa river. Lothal was a thriving port as well as an export center of beads and gems. It was an industrial town. Upper Town or Citadel is located in the southeastern corner of the site. It is built on 3.5 meter high platform, evidence of a large structure that could have been a warehouse within the citadel. In Lower Town, a bead making factory has been suggested by the experts on the basis of evidence. In Lothal, all houses had their own private toilet, which were connected to a covered sewer network constructed by baked bricks with the gypsum lime based mortar. Common houses had a bath on platform. It connected to underground sewer. Toilets were connected to the pit or cesspool, which were also connected to the sewer line through the earthen pipe or trough. People of Lothal had developed intricate drainage system and sophisticated brick cisterns for cleaning. These were equipped with aeration chamber with lime and charcoal filter. Most unique aspect of planning the system of underground drainage, the main sewer 1.5 meter deep and 91 centimeter wide across connected to many north south and east west sewer. It was made by bricks and joined together seamlessly. The expert masonry kept the sewer watertight, drop at regular interval, act like an automatic cleaning device. Level and slope also the key feature of these sewers. Main sewer carried the waste water to the main channel connecting to the dockyard and the river estuary. A rectangular structure 218 meters long and 37 meters wide, identified as a tidal dockyard in the eastern side of the town, made by baked bricks. Some scholar and historian think that it was an irrigation tank. Criticism of the dog theory has grown since first doubted by Lesnick in 1968 and later Euler in 1982. The tank is most scientifically designed to withstand the flow of water through the tidal current. It also had a water locking device to keep the water in. At the northern end of the town is a basin with a vertical wall, an inlet in north side connected through a stream of river, and outlet in southern side connected with a canal. This has been identified as a tidal dockyard. The river channel would have brought a considerable volumes of water during high tide. This would have filled with water and facilitated the sailing of boats. The basin exhibits a remarkable knowledge of hydraulics and tide. People of Lothal studied about tidal waves and they constructed a dockyard away from the main current of the river to avoid silting. A stream of river diverted in southern side as a deep passage towards the basin or dockyard to access the ships in high tide. There was an inlet in northern side of dockyard and an outlet in southern side connected with a canal to maintain the water level through the wooden strips or earthen bund. Scientists from National Institute of Oceanography, Goa discovered foraminifera, marine microfossils, and salt gypsum crystals in the rectangular structure, clearly indicating that sea water once filled the structure and it was definitely a dockyard. Additional evidence finding of 5 stone anchors and assurine cells from the dockyard, 5 terracotta model of boats, and a circular Persian Gulf seal from Bahrain. Remote sensing and topographical studies published by Indian scientists in the Journal of the Indian Geophysics Union 2004 revealed an ancient river adjacent to Lothal. According to satellite imagery, an ancient extension of northern river channel bed of a tributary of the Bhogwa river, a small channel width 10 to 300 meters, suggested that presence of a strong tidal influence upon the city.